going to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, and you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi, my name is Nikolay Stanoev. I'm working for Isobar UK as a QA architect, and I'm from Bulgaria. My topic is related to web automation and how to create e-commerce framework which can be used by every person besides of his automation knowledge. Thank you.
Hello everyone, and thank you for being on my talk today called Universal Web Automation Framework. Agenda for the current session is to speak a little bit about Isobar vision for web automation of e-commerce applications, to go through over the architecture of the solution that I'm going to present, what we do in terms of test executions and reporting, some tips which might make your life easier, how we solve the knowledge sharing gap, and at the end I'm going to complete with a lot of examples. During the session, I will refer real examples what we did in collaboration with Adidas for the last 4 years. But before I start, I want to tell you a small story, which is based on my experience for the last 11 years as a QA. Every company which does automation has automation experts. Those people has a lot of knowledge and build almost everything which is needed. But having such expertise in every QA member goes with a high cost, where not every company is ready to pay. Due to that, those experts are usually than 10%. Over the time, they start working with people who are eager to learn, has potential, and looking for challenges. This way, the knowledge is spread within more and more people. At some point of time, skills are improved, challenges goes down, and people start changing their jobs. So the knowledge sharing loop start again with new faces. That's why our solution for this problem is to make the automation of our application in universal way, where every colleague will be able to use and contribute. Our vision matches the following goals. Automation which we build must be easy to extend, with higher usability, low learning curve, and last but not least, usable by everyone. In the next slides, you'll see how you can achieve this. The tools and frameworks which we use are Selenium, Java, Python, Cucumber, TestNG, and SonarQube. Of course, the idea can be applied for every programming language which has Selenium binding and BDD testing framework. On this slide, you see 3 layers. The first layer is the core one. It contains main functionalities which are needed for every project. Next one is XSys. Those are all external systems which needs to be automated but not tested. Some examples are backend system for your application in order to update test data, preferences, and configurations. Another example might be the backend payment system, where you want to validate how your orders goes through, what is the fraud score, and some other information from scoring perspective. The last layer is the application which we're going to test with our automation. Now let's move a bit deeper on each layer. starting with the core one. Selenium is our core tool which we use to do browser testing on desktop browsers and real mobile devices. That's why we have a Selenium wrapper which consists of every Selenium action that will and can be used in automation. This way, if Selenium deprecates or updates some method in the newer version of their releases, we'll need to update that change only in one place. Next one is browser capabilities. This is the place where we defined what are the possible options for browsers to be tested. In our case, we have hard-coded values which can be used by default, but we also have a capability to override them with what we want in order to run the tests on different browsers or devices on demand. Selenium Grid integration is also part of the core project. This is the place where we stop browsers in our Selenium Grid. It could be either local Selenium Grid, it could be a browser stack or source apps. Next one is HTTP. This is a wrapper of all HTTP requests. The idea behind this is to have an easy way for our colleagues to do HTTP calls just by providing request URL, request type, body, and headers. As part of this, we have a response object which can convert the result to string, JSON, or XML format, plus everything else like response status code and headers. Last one is listeners. Either for collecting information, test updates in other systems, or run functionality, all those are implemented here and reused in other projects. So this is how our core project looks like, and this is the first layer which we implement in every other project which we have in terms of automation, steps on it and get everything for free. Moving further with Axis layer, you can consider every system which is different from the one that you test as external. Few examples from our cases is Salesforce Commerce Cloud Business Manager, Adyen Backend Console, and CyberSource Backend Console. We call them external systems because we want to validate and update some information inside of them. We do not want to test them, only validate and verify something it's properly propagated and filled. The key thing here is the execution time. If you have enough knowledge and access to documentation of those systems, the suggestion is to check for API. If the system has such API, use it. This is the best way to automate external system, and as a result, it will reduce dramatically the execution time of your tests. If API is missing or it doesn't cover what you need to do, but still application has web UI, you can try automating the external system via HTTP calls, which represents user navigation in the browser. This is fast as well in terms of execution time, but it requires a lot more effort and skills to be done. Last option, of course, is to use Selenium by starting a new browser and automate it as a regular application. This is the slowest way and the one which is less recommended, but still an option if the other two are not possible. And also, if we don't know how to make an API and HTTP calls, Selenium is still an option that we can use. Last thing I mentioned here is Cucumber. It doesn't matter which option for automation you will pick. Important is to make a respective action exposed via Cucumber steps in the project itself. This way, every other project which needs to interact with the same backend system will be able to use it out of the box, and whenever a change needs to be applied, all projects will get the update for free. The last layer is the application, which we need to automate and test. Again, here you can see three different layers: page, module, and steps. We are using a page object model for automating our web applications. Every page class needs to contain selectors, actions, and verifications. Depending on how big is the page that you need to automate, you can split it logically in several different classes and group all of them in a single package. Next one is module. This is where we group all our methods from page classes in one logical user action. Example for such action is filling payment form with credit card information on payment page. Module layer is also the place where we do data manipulations if we have such. Imagine that we have a drop down on the web UI which accepts two values, yes or no, and then you provide this from the cucumber step. But later we have an HTTP code which expects those yes, no to be converted to true, false. Such kind of data manipulations, we make them on the module. And the benefit of this is that if in future you decide to go with different BDD framework or any other testing framework, you can put it on top of the modules and it will work for you with some small changes. Last layer is a step. Here we have all step definition classes separated on pages. All transformations and BDD context objects which shares the state between steps are also in that layer. Methods inside step classes call directly respective methods from modules with data which is provided inside of the step. Pros of this approach are clear, easy to maintain and understand with low complexity. And here by easy, I mean every person will be capable to update the code if something has changed. Cons are too many classes and packages. In general, this is not a problem at all, but if you have a lot of things already implemented, it might be a bit difficult to find what you need, especially if you're looking into functionality which is not maintained and automated by your team. Next one is pull request conflicts. When there are a lot of people working in parallel, the chance for pull request conflicts increases a lot. In our case with Adidas, we have more than 50 colleagues who are contributing daily onto the automation activities and the code. And especially when you have people who are still catching up with the knowledge versus those who are working with decent pace, those pull conflicts will become a trouble. Now, let's talk about test executions. I have seen projects where people do automation which runs only on their machine and it starts by clicking a run button on their IDE. This might work for some cases, but in general, you need a CI/CD tool where you can schedule your executions and to run them over the night or on demand. As a result, your machine will be free and you can do something else while tests are being executed. In order to reduce the execution time, you need to run your tests in parallel. There are many ways how you can achieve this in Cucumber, but we have implemented only two of them. The first one is every time when we execute our Jenkins job, we have a runtime property which can be set to a value from 1 to 20, and this is going to refer to how many scenario outlines are going to be executed in parallel. And because of the way that we have automated the application, in some cases we need to use a connection to browser stack via their local driver, and this reduces the maximum number of tests that we can run in parallel. The other way that we can run the tests in parallel is just spinning different Jenkins jobs with subset of tests that can run in parallel. This way we can run, let's say, 4 jobs in parallel, everyone to run with 15 tests in parallel, and to have a total of 60 tests executed in parallel at the same time, which again is a nice way to reduce the total execution time if you need to have a quick feedback look, during the day. Next one is gather information. While tests are running, try to capture all the information that might be useful for you. In our case, as I mentioned, we use browser stack, and all our tests are executed with enabled networking logs, enabled console logs, video, and screenshots. So if the test failed, we have an automatic way to fetch a browser stack session URL and to put it into the Cucumber report, so it will be easier for people to navigate and see what has failed over the night. Next one is think, best QA skill. Add capability for running only the tests which you need. This means you need to have an easy way to say which test to be executed and which one to be skipped. In our case, we use a tag called disabled. So if the test is part of the execution, but it has a tag disabled, it will be automatically skipped and not run. As part of that, you can use tagging in a smart way. As I mentioned, we can run our tests in parallel, but if you are going to run exactly the same set of tests in 3 different Jenkins jobs, that doesn't make sense. That's why we have a priority in our test cases, and each test case can be prioritized by low, medium, and high tag. As part of that, we have also a functional tag, which is calling checkout area, my account area, product listing page, product details page, and so on. So we can easily say I want to run only the high priority test cases from checkout area on one of the Jenkins jobs, and on the other I can say, okay, now I want to run medium priority test cases for the my account section, and those jobs are going to fetch and execute only those tests which are matching that condition. The last one is nice to have feature which solves partially the problem with flaky tests. By flaky test, I mean a test which, if you run it manually, it is going to pass. If you run it 10 times by automation, there is a chance sometimes to fail. This is called, from our understanding, a flaky test. And the reasons for such kind of tests is either there is a background process on your applications which is running and it's consume a lot of memory or CPU utilizations. It slows down your application, and then the test is hitting some timeouts and it's failing because something was not loaded for 10, 20, or 30 seconds. Another example is if you have connection issue with browser stack, there isn't a device which can execute the test. It goes into the queue, but into the next 5 or 10 minutes, still there isn't a ready device. Then it will be dropped from the queue and the test is going to fail. Such kind of issues can be solved by up to 80% if you have implemented a rerun functionality, which is going to fetch all the tests which has failed initially and execute them one more time. Moving to reporting. From reporting point of view, we use default Cucumber report because it has everything that you really need. It has trends, so you can see over the time how many tests were executed and what was their fail rate and pass rate. Also, there is information about image, stack trace, and all other things that you need to put into the Cucumber report to be easily for investigation and analysis. So Cucumber gives you that freedom and you can really use it. Why you need another set of reports. As part of that, you also have a tracking with how many steps were executed, what was the average time for each steps to execute, and the total number of time in terms of execution time. So it's easy in future to say, okay, let's do something on the execution time, and based on the analysis, you can start with the steps that are taking most time. Next one is auto updates in the test case management system. When test execution completes, we have an update in our respective test case management system, which is either X-ray or TestRail, and create either a test execution or test run with all the data. This way, if something happens in our Jenkins and we lose data, we are backed up because we have everything in our test case management system. For easy mapping between all of the systems like Jenkins, where we start the nightly execution, from the test case management system, from the API tools which we use for visual test automation and their UI backend, we have this using the same mapping for all those systems in order to make the chain and see where the test artifacts resides. It is Jenkins build name plus Jenkins build number. And this make unique experience for the user to identify where exactly are the results from the current Jenkins job. And for everything else in terms of reporting, you can use your test case management system and provide the results which might be needed for your management. If you wonder why we have Python on that image, the answer is pretty simple. It is just a quick challenge in our pocket for the people who are eager to learn new things and want to face more challenges. Moving to the section with the tips, which will make your life easier and help to reduce complexity in general. I'm starting with the documentation because this is a critical one. You need to have an excellent documentation which contains information about all runtime options and values which can be provided for them. If there is dependency between these options, add this as information as well. Example for such dependency is combination between browser and environment where you want to run your tests. For example, you cannot run Safari on Windows environment, or at least you cannot run it for the latest Safari browsers. That's why such kind of problems which might occur make sense to be added as a dependency information so people to be aware of them. As part of the documentation, it makes sense to add information about IDE setup. In our case, we use IntelliJ, so we have a proper documentation which says how to install IntelliJ, how to configure it, how to build it, what kind of runners to create, and test run configurations in order to run your tests. Everything is documented in our documentation, and people can go through it and set up their local environment without asking questions, and even will be able to execute some tests which we have in our placeholder feature files. Next one is coding examples about how to solve certain problem. So people can always check them and try to use some of the approaches there to solve their problem. Quick examples are handling the checkboxes or drop downs. You can have it into the code. You can even refer it to the code where it's exactly used, but it makes sense to add some explanation so the people to go through it to see the solution and then try to reuse it. Another point is setting up CI jobs. In most cases, from my experience, people know Jenkins, for example, as a system where they run something or download artifacts, nothing else. From automation point of view, we use Jenkins in order to execute our nightly executions, and it makes sense people to get more knowledge about the system in order to configure new Jenkins jobs and to schedule them and to run whatever they need. So adding such kind of documentation is going to help to every person to go through it, read it, and set up a Jenkins job for their needs. Also, the maintenance after that is going to stay in their hands. And just an example, in IDAS, we have more than 15 teams working in parallel, and each team is owning their CI jobs. So all the manipulations, all the data are in their hands. Last but not least are some guidelines for doing analysis of failed tests. If people start with the best practices for analysis since the beginning, they will be a lot more efficient in future and will not lose time for wondering how to reproduce certain issue or why has the test failed. Another tip which might help you with flaky tests is data auto IDs. This is an approach which we use since 2017. This is a custom attribute with specific value, which is used only by the automation. How this helps? First, it solves the problem with complexity for finding the right locator strategy for identifying your Selenium elements. First, you don't need to think how to write complex XPath or CSS selectors. You can just use CSS selector, which is saying data auto ID attribute equal to some value or starts with some value. This way, the complexity for finding the right locator strategy goes really down. And at the second, if you use this, your code will be a lot more stable and independent from CSS and HTML changes. The reason behind that is you will not use any more CSS classes in order to identify your elements because you already have a custom attribute for this. So the dev team is fully unlocked to apply any kind of CSS changes, and your automation will still going to work. Of course, if they rewrite completely the solution and the logic, then you need to recreate it as usually. Last tip is to build a community. Create a chat, channel, or group in your communication tool and gather all people who will work on the automation. It makes sense to add every person who is supposed to work on automation since they join in the project. This way, they will have enough time to see how people work, communicate, and collaborate in that group. Set up a friendly environment, find time for jokes, funny pictures, which will make people feel more comfortable. Remove any limitations in terms of skills, positions, and even companies. A quick example in our automation community in Adidas is consisted of people from 5 different companies. Last but not least, promote people for sharing ideas, asking questions, and seeking for help. Make them feel that this is the place where they can speak up without any limitation and will find always support by the rest of the team members. If you do this, the result will be a self-sustained community which can create leaders and possible superstars from technical and communication point of view. Another problem which is often faced is the knowledge gap. Next few slides, we will share how we solve it in Adidas project, where we have more than 50 people working on the automation. First one is to have an action plan. Every time when there is a question or a problem, we were discussing it in our automation channel. If the answer was somewhere into the documentation, we were referring to the right location and leaving the people to go through it. If after that there is still a problem, some of us was jumping on a call with that person, working together in order to identify what exactly was the problem, what was missed, or is there something that needs to be changed or updated. Based on that, either documentation was updated or we were again asking the person to go through the documentation one more time and highlight what are the important things that he has or she has missed. As a result, we have to maintain our documentation to be always up to date. Example why this is important, in our case, we have all our passwords shared for external systems, shared in a Confluence page with limited access. So in order to run your test locally, you need to get the passwords from there, set it up in your local IDE, and execute the tests. If someone changes those passwords, first they update them in Confluence and share them in automation channel. And then it's responsibility for every person to pick up those values and update them immediately into the local ID, because if they run some tests, they're going to fail because of the password change, which is going to result in locking of the account. And when our nightly execution is executed, a lot of tests are going to fail because of that failure. Account is already locked. And in the next morning, we're going to have a lot of failures and will not have any information about the results and whether we can go with the daily release or we need to skip it. That's why it's critical to have that documentation up to date and people to follow the process. Next one is dedicate enough time for people to go through documentation and to play with it while they are reading it. In most cases, I have seen that it is really boring for people to go through documentation without any interactions with the application that they need to automate or they need to set up the local ID, and they don't have questions. So once you give them a real tasks, they start asking the question how to do this and how to do that. That's why while you have preparing your documentation, put the challenges inside of it, put key places where people need to go and to set up something locally, or they need to run something locally in order to achieve some certain result. This way, you will be sure that first it will be a lot more fun for people to go through the documentation, to read through it, and even to set up everything. And at the end, they will be really capable to start working on the automation. Last one is knowledge sharing sessions. And here the idea is to make them whenever you see that there is a need for them, or regularly if you have a lot of things to share. Another good idea here is do not make those knowledge sharing sessions only by the most senior people. Make them even with less experienced people who has that knowledge. Of course, be always with them in order to support them if there are questions that they don't feel comfortable to answer, or they are afraid to answer because they're not sure how to answer it. So be there and support them. Next one, leading by example. Still, we are one community and we are working together. So prioritize your colleague. Prioritize your colleague support. Whenever someone is having a problem, focus on it and help them. This way, you will improve their motivation and happiness, because they will always know if there is a problem, there are people who can help them. Be active and push people with potential to extend their comfort zone by asking them to answer to questions or work in parallel with people who need help. This way, more experienced one will be able to develop mentoring and other soft skills, which will be in use in future. And last but not least, accept the idea that people cannot learn with the same speed. Due to that, find the quick learners and spend time with them so they can boost the automation coverage. For the people who needs a little bit more time to understand the things, be patient. Give them the time and support them when needed, because you never know who can become a superstar after a year or two. And here you can see some of our Isobar superstars working on Adidas project. All of them are a crucial part of our automation community and are always there to help and suggest improvements. Important to highlight here is that some of the people on those images started as interns and almost zero automation knowledge, and for a few years they become leaders in their teams. I'm coming to the end, so in the next few slides we'll share a few more examples. This is an example of our Cucumber test case, how it looks like, and we call this as a shared test case. The reason behind that is here you don't see a real values which are used by this test case. What you see is just the keywords. And the reason behind that is in Adidas project, it is a multi-market and multi-locale solution. So there are a lot of test cases which can be reused and re-executed with different values on different markets. For example, the same test case for placing an order with credit card can be executed on US, UK, Germany, France, Latin America, Pacific, Southeast Asia, every other market that Adidas has. It can be also executed for different brands like Adidas and Reebok. So instead of writing a lot of test cases which are following the same steps or just extending the example table with a lot of scenarios that we don't really need to execute every time, we have a simple placeholder and single scenario outline with some keywords which can be updated by the Python script runtime with the values that we want to execute. This is another example of a shared test case for different project. And here you can see this is the mapping with our test case ID in our test trail system, for which configuration this test case must be executed, what are the functionalities which are covered by the test case, and for which markets the test case is applicable. Again, the table with scenario outlines is fully parameterized. Here you see how the folder structure looks like. In the features, we have a folder for each country, and in every country, we have several feature files based on functionalities, and they has only test cases which are applicable only for that market. We also have a shared folder which contains, again, feature files with split based on functionalities, but the test cases inside of them are applicable and can be executed for more than a single market. And those are the two placeholder files. The first one is functional test example. The next one is visual test example, which we use as part of our documentation, and people go through them in order to set up and run the test for the first time. On the right side, you see the properties files and how we group them. First, we have a separation on instance, development, production, sandbox, and staging, because those are different instances where we execute our test cases. And in each instance, we have respective properties files, which can be executed for each country. This is an example how our property files look like. On the left side, we have examples, which are the keywords. And on the right side, we have the values, which are runtime updated in our code in the feature files and then executed. This way we can ensure that when you see the report in Cucumber, you won't see the keywords into the example tables, but you'll see the real values. And if you are a manual QA who needs to do analysis, you can go step by step and reapply the values that are put by the automation and see the results. Next example is again from Adidas project. And when we were ready with the automation and covering all the markets, because that was one of our main ideas when the automation in Adidas started, a manager of the marketing team came to me and say, hey, I know that you're covering everything and everyone speak about the automation that you did. Let me tell you what is my problem and tell me what we can do. So she came and said, we have 4 or 5 URLs. We're working on the campaigns in Adidas. We usually need to verify how the campaign looks like on 4 or 5 different URLs for all 36 markets on all 44 locales. And we need to do this on different devices and different screen resolutions. Usually this takes around 40 hours to my team in order to complete that work. How can I use the automation in order to reduce that time and to have results quicker so we can do something different after that? I saw what are the problems and saw what they do, and then I suggested to use Apply tools in terms of visual test automation with our automation, because we already have integrated Apply tools and we have it as implementation. So we said create a functional tests, incorporating them visual verification, create a baseline in for the visual test for the main language markets like UK for English, Spain for Spanish, Germany for German, and French for France. Then execute all other OKLs to be compared against all English OKLs to be compared against English UK results, all French OKLs to be compared with French OKL, and all Latin America OKLs to be compared with the Spanish OKL. This way, you're going to solve the problem with the translations because they're localized on different languages, and the images should be still the same. You can capture this via the automation. You can set up your Jenkins jobs. You can run them with different viewports and see the results. And she said, that's great, do it. And I said, yes, but we don't have time. We still have another stuff to do and to increase the coverage. And I rejected that idea. What I proposed is we have a great documentation. You can go through it and try to set it up. Still, it's 40 hours per week, so you can spend 2-3 hours per day for working in that direction. I can support you every day by 1 hour in order to unblock you or explain how the things happen. And then you will be able to create your test cases by your own, to analyze them in Apply Tools backend console and see the results automatically by yourself and get quick feedback. After 1 month of work from their side, in total it was less than 15 hours from my side, they were able to understand how the automation works, to create their test cases, to start analyzing them in Apply Tools, and even to increase this for every campaign. The result was that they have reduced the total time from 40 hours to less than 10 hours per campaign, and were really happy about that. So at the end, this really showed us that what we have done is really a universal automation framework where everyone can use and contribute to it. Thank you. So now let me jump to Slido. I don't see any questions. If you have questions, you can ask them into the chat and I'll be happy to answer. If not, I'll be after that into the Ask Me corner for the next 20 minutes, and you can also ask questions there about the topic.